further ado, please welcome to the stage, Kira Rockwell.
What a gift it is to join together on this snowy Saturday to celebrate the creative forces buzzing inside each of us, inspiring us to turn original ideas, Post-it note sketches, and mood boards into a new, innovative tomorrow. I'm honored to introduce our dazzling keynote speaker, Vanessa Clark. Vanessa is co-founder and chief executive officer at Atomos Space, with the goal to remove the barriers to accessing space that she experienced in her roles both as a launch vehicle designer and spacecraft developer and operator. Vanessa is an experienced aerospace engineer with a background in advanced physics and mathematics. She has worked as a research engineer, led the design, testing, and production of spacecraft systems for NASA, and much, much more. Vanessa is passionate about promoting sustainable space utilizations and realizing next-generation space-powered technologies that will enable humans to access space beyond Earth orbit. Vanessa is here with us today to share her story and answer some of your burning questions. Now, without further ado, please welcome Vanessa Clark.
Thank you, Kira, and thank you for the kind introduction and the invitation to come talk to you all today. I want to start my talk with a secret that I haven't really told many people. When I was in my early 20s, I changed the course of my career, my field of study completely. I was about to start a PhD, and suddenly I decided not to, because I was scared. I felt that I wouldn't succeed doing a PhD. I felt I wouldn't succeed in academia. And I felt all of this because I believed that I had not had and wasn't capable of having original ideas. Today, I hope you leave with the words I wish I had heard more than 10 years ago. I hope that you build the confidence to recognize your ideas, trust them, and have the courage to pursue them. The problem that Atomos Space is working on is near and dear to my heart. I didn't just experience it in my later career in industry, I also really researched it and understood it. The problem I care about is that the most impactful, world-changing satellites simply aren't being built or launched to space. These are satellites that can connect the billions who don't have internet. They're satellites that can help contain environmental disasters, support climate change research, and in the future, provide global green energy. The reason these satellites aren't being built or launched is that rocket launch is too expensive. Rockets were originally created for military use, designed for a single payload with little consideration to cost. And now, 70 years on, we're still using the same single-use rockets to put not just military, but commercial and science satellites in space. Launching satellites one at a time creates a schedule bottleneck. Wait times can exceed years. It's expensive. It's inefficient. It's like flying passengers one at a time in a single-use Boeing 737. And it does not need to be that way. At Atomos Space, we are building and soon operating orbital transfer vehicles, or space tugs. With space tugs, a launch vehicle no longer needs to go all the way to a specific orbit for a specific satellite. With orbital transfer vehicles, satellites can ride share on rockets. A rocket can take multiple satellites to a low, easy-to-access orbit, and our orbital transfer vehicles take them from there and do the last-mile transportation. This simple shift in logistics drastically reduces the cost to launch and operate satellites. As the CEO of a space company, I am often asked, did I want to be an astronaut when I was a kid? The answer is yes, but back then I was too embarrassed to admit it. until one particularly memorable high school physics class. My high school physics teacher was a little eccentric and would go off the curriculum. And this one lesson went like this. He starts reading from an audio transcript from the Apollo 9 mission. It's just mission control asking the astronauts to do some checkouts and the astronauts responding with figures and numbers. But all of a sudden, the banter is interrupted by one of the astronauts who's looking out the window. He's gasping, he's pulling his crewmates to look out the window as well. They're saying, "Oh gosh, look at that." One of them exclaims that it's the most beautiful sight he's seen in space. My teacher stops and asks, what were they looking at? So we guessed, and we all guessed wrong. Our guesses range from sunrise from space, or stardust, or Earthrise from behind the moon. My teacher kept reading. The astronauts were watching a urine dump. When urine hits space, it solidifies immediately. And so they were watching this golden globe of urine float by their window in slow motion. And it hits the side of their spacecraft and slowly explodes like a golden chandelier into 1,000 golden shards, catching the sunlight. 16-year-old Vanessa thought, oh wow, I want to be able to tell anecdotes like that at cocktail parties. I think I want to work with the weird and wonderful every day. So I started talking about working in the space industry. I started a degree in physics and mathematics. It sounded hard, but also urine dump story. And here is my second secret of today. I completed that degree with really good grades, but I feel like I didn't learn a thing. And maybe a lot of you feel that way. Back then, I felt that my best skill was rote memorization and regurgitation. Give me any dynamics problem, algebraic problem, complex numbers problem. I could learn how to do it, solve it, repeat with different numbers in a different context, in an exam setting. After exams, I forgot everything. And so when I went to pursue my further career, I felt like I couldn't do a PhD, where I was being asked to expand the knowledge of humanity. That is very different to everything I did in my undergrad, and I didn't think I could do it. So I swapped to aerospace engineering. Now, it sounds very similar to physics, but in engineering, you have a set process and set rules that you can follow to design a machine, which, no pressure to expand humanity's knowledge, right? So I changed degrees to aerospace engineering, and it turned out to be a really great fit. I loved it, but I still felt like I was faking it. When I was getting close to graduating, even though I wasn't becoming more confident in my skills, I was more confident in what I wanted out of life. So I started bending the rules. I finished my degree in Germany, even though studies abroad weren't allowed. Even though I had to beg to have those credits applied to my degree so I could finally graduate, it was worth it. I landed a job at a rocket manufacturer in Germany. And then after that, I went and worked for the German Space Agency. Now, this is where the story of Atomos Space begins. Working at the German Space Agency, I was put on a really weird project. I was part of an international research group that was designing a space tug to take payloads to Mars, Jupiter, the deep solar system. Now, I didn't know what a space tug was when I started, but fortunately, because the German Space Agency was much more organized than its international partners, I was actually hired 9 months too early, which was great. I had 9 months to learn all about this, so I didn't look like a fraud. So I did what I always did. I looked at what had been done before. I found papers and books from NASA and the Russian Space Agency to look at what is a space tug or an orbital transfer vehicle, what technologies are best for them, and how do I design this? I started replicating some of the results that I saw in these NASA papers, building up computer models and simulations of different types of space tugs. And then I found some things that worked really well and some that didn't, and so I started mixing and matching, still just copying everything that had been done before. And then I ran an optimization. I thought I had a pretty good design. Feeling a little confident, I went and asked a colleague if I could use his orbit analysis tool. This would tell me how fast my space tug could go. Anyway, I ran the numbers and was shocked to see that I could get a crew of 4 astronauts from Earth to Mars about 4 times faster than anyone had previously reported. Whoa, I'd made a mistake here. This seemed to break physics and was wrong. So I kept working, sure that I had missed something. Meanwhile, the project started with our partners from various European and Eurasian space agencies. These were engineers and scientists that were much, much more senior than I was as a recent grad. And after 2 months in the project, it became really apparent that their design was converging on something very, very different to what I thought was the optimal. But I said nothing. I was sure I was wrong. I was sure I had made a mistake. The project concluded without me really having any input into the design. But it kept nagging at me, like, what had I done wrong? I want to find out what I was doing wrong. And after weeks of looking at the numbers, computer models, physics, I couldn't find a thing. I felt maybe I had created something original. I didn't tell anyone. Meanwhile, with that project wrapping up, I changed jobs at the German Space Agency, and I went back into rocket design. A year or so later, my manager tasked me with reducing the cost to access space. It's a very, very general task to give someone, and I took his words literally. In retrospect, he wanted me to design a slightly more efficient or a slightly cheaper rocket, but I went back to basics. I looked at who is launching to space and why. Where do they want to go to space? How much are they paying? And why does it cost that much? And then finally, do we need rockets at all? And I found 2 things. One is what I told you earlier. The most impactful satellites just simply aren't being built and launched because the cost to put them in space is such a barrier. The second thing I learned is optimal logistics, clean slate. Let's start back in the 1960s and do this properly. Is rockets should take payloads to a low, easy-to-access orbit. Then we should use a different system that's already in space to move those satellites to their final destination. A system that actually looks a lot like this crazy space tug that I'd already designed. Anyway, I handed my report to my manager, and he thought my research direction was really weird, and he shelved it. But it didn't matter. I had found a problem that I'd cared about, and I had confidence that I could have original ideas. Now, how long do you think it was between that incident and starting Atomos? It was more than 3 years. Part of the delay is I didn't have the confidence to go do this, and part of it was I really didn't feel like I knew anything outside of designing satellites. I didn't know how to operate them. I didn't know how to build them. I certainly didn't know how to launch them. So I moved to the US and got experience in all of those things. But during this time, I kept talking about my idea. In fact, during my interview for my job here in the US, I told my manager during the interview that I saw myself leaving his company in 2 years to start my own. And luckily, he still hired me. But it's also how I got my first supporter and my first investor. A guest speaker at a conference very similar to this that I had hosted years earlier flew from Europe to the US and sat me down at lunch in a very fancy restaurant and said, Vanessa, I remember your idea. I believe it is needed, and I believe you can do this. Those words of encouragement caused me to quit my very comfortable job, find a co-founder, nearly go bankrupt, raise millions of dollars in venture capital, win millions of dollars in contracts from NASA and other US government agencies, build an amazing team, and build some space tugs that are going to launch next year. And it was a journey to get there. So the lessons that I want you to take away from this is that original ideas can be old things applied in new context, or two old ideas kludged together, or really just refreshed old ideas. Like, if you doubt that you can have an original idea, go back and talk to Vanessa from a few years ago, and she'll be on the same page as you. Like, all of us can have original ideas, and what is an original idea is up to interpretation. The next thing that I recommend is, if you have a problem, go back to first principles. Don't just try to optimize what already exists or incrementally improve it. Look at the world with a blank slate. The sky's the limit. The next thing that I hope you all learn from this is that sometimes experts don't have the best expert opinion. The next thing that I think has been really powerful was trying to find and fix my blind spots. I learned so much with the idea in the back of my head while I went out into industry and did different things. Next, talk to people about your idea. Not just for cross-pollination, not just for validation, but also so that you build some social peer pressure so they expect you to go do these great things. You're not going to let your friends down. And the last most important piece of advice that I have is learn how to filter feedback. There is a reason why this one woman who sat me down to lunch and said she believed in me made so much of a difference, more than the hundreds of people who've told me that I'm crazy before and since. I looked at her history, I looked at her background. She was the vice president of a renowned satellite company. She was building satellites, and I was eventually hoping to build an orbital transfer vehicle to serve her company. She knew the problem as well as I, whereas the friends, potential investors, potential employees who I spoke to after the fact who said I was crazy, they didn't know the problem or the solution as well as this one person did. So try really hard to keep going if you get negative feedback, but also keep in mind that sometimes that critical feedback is stardust and not a urine dump. I'm going to close with one quote from an investor of ours, who's also an entrepreneur. All great ideas start as weird ideas. What seems now to be really obvious early on was obvious to nobody. So go out there, come up with, and then build some weird ideas. Thank you.
Thank you so much, Vanessa. That was truly so inspiring, and I'm so excited to chat with you over here with the fern. Oh, you guys are gonna move it up. Thank you so much. Wow, can we just clap again for Vanessa? Hello, hello. So I have the pleasure of asking some questions first, and then we're going to throw it to you all to ask some questions. My first question is, earlier in your career, you made pivots. And I'm wondering, advice for folks who might be feeling that need to change and make a pivot. What advice can you give to them?
I think the biggest piece of advice that I can give is don't fall into the sunk cost fallacy. Even if you're near graduation of a degree that you don't think is a good fit, the penalty of not changing is worse than the penalty of stopping what you're doing. So just make the change, particularly if you find in your day-to-day job you don't like it.
Ain't that the truth? I loved how you framed your time in Germany as you starting to bend the rules. And I'm curious what your relationship to rules and following the rules and how that's evolved.
So I think about this in two ways. So our company is not a move fast and break things company. We do innovate a lot, but the things that we break is convention and not rules. We actually work really closely with regulators and have helped write some policy in the past. The rules that can be broken and should be broken is convention and basic assumptions. So one of our philosophies as a company, as we grow, is that every assumption behind a decision needs to be questioned. I think we've all heard the anecdote of monkeys in a room that refused to pull a lever to get a banana because previous monkeys had electrocuted themselves in doing that. Like, don't fall into the trap of repetition and the tropes of what has been done in the past.
That's great. You shared a little bit about your conversation with your first investor and this dinner at this fancy restaurant that started at a conference just like this that we're all at right now. And so I'm wondering, how can we build relationships with folks that might one day in the future, which you don't know in the present moment, could be someone important on your team. How did you foster that relationship with this individual?
So I was one of the event organizers, and back then we were really nobodies. We were hustling, trying to get funding, going out and pitching prospective sponsors and guest speakers, and often we didn't take no as an answer. But often people like myself or like this investor really want to help the community. And so that's how we got in with her. And we convinced her that by staying with us and helping support this community, she could help foster a talent base in her town that would eventually help the space industry. And from there, our relationship grew. But I think one of the key things was that I would come back to her and ask her for her opinion. People like me and her love talking about ourselves and about things that are really problematic for us. So if you ask me some problems about my business that I would want solved, I have a list of 20 things. And that's what I did with her. I went and asked, okay, from your position in the company, what are some of the things you just wish you could wave a magic wand and solve? And so by asking questions like that and not lecturing, not providing immediate solutions is really how I started building rapport with her.
That's great. Just meeting on a human level, is always important. And I feel like I could sit here with you and talk all day, and I wish I could. Maybe we will. Hey, I'll take you to a fancy dinner, okay? One day. So my final question before I hand it over to you all, you had shared that whenever you were working in Germany, your boss had said, where do you see yourself in 2 years? And you said, running my own company, which is so inspiring, yes. And I'm curious, where do you see yourself in 2 years today?
Probably doing exactly what I'm doing right now, except instead of having a team of 20 with a shoestring budget, it'll be a team of 200. I've found a role that I love and an industry that I love, and I care deeply about the problem. And no matter how hard it is to keep going, I'm inspired to keep going. And so it's easy to kind of plot the future when I enjoy every day. Well, parts of every day.
I love that. That's enjoy every day. And you're about to launch these tugboats into, what did you call it? A tug?
So a space tug or an orbital transfer vehicle is the very specific term we use in the industry.
Space tug. I love
space
that.
Tug.
Okay, well, we are fans of you and we're supporting you and can't wait to see where you go. So questions from you all for Vanessa? Yes.
Hi, my name is Ingrid from Tufts University. You mentioned about you first started only knowing how to do rocket design, but we need all sort of soft skill and hard skill for entrepreneurship. So what is something that you would like to pick up? Or what is something that you feel like you have to hire someone to do it for you?
Oh my goodness, everything. So what I've found that I am really good at, which I never thought I would be good at, is what I've kind of morphed my job into as a CEO, which is sales. Sales are all about relationships and about inspiring your customer and then inspiring confidence in the customer. The next thing that I do is fundraise, make sure that our company has enough capital to do what we want, which is basically a type of sales. I never thought I'd be in sales or ain't good at it, because when I was growing up, I was really shy. And then the last thing that I do, that I think I do a really good job at, is setting the company culture. And that requires empathy. And so my day-to-day, I really don't operate in an engineering or technical space anymore at all. unless I'm having a technical strategy meeting with our chief engineer. Some of the gaps that I found that I had to fill is I am not a details person at all. Like accounting, regulatory affairs, detailed design, like all of those things that really need someone who has an eye for detail and is perfectionist, I have hired people for. Like I am definitely not the person to be proofreading a press release before it goes out because I don't like reading anything after the first draft. Like what else are we hiring for? And then I think the last thing that I was surprised that I really gave the reins over was we brought on a chief engineer, not because I couldn't do it myself, but because I didn't have the time to do it. With fundraising and sales and setting the culture and helping a little bit with the roadmap, but finding someone who was really aligned with where I wanted to go, but with a slightly different skill set, has really helped our company.
Thank you. Yes. Oh, right here in the front. Right here. Oh, okay, never mind.
Where do you fit on the spectrum between SpaceX and Blue Origin?
How would you define the spectrum? Is this innovation? Is this speed? Is this risk? Is this ambition? Like, I can think of a few different spectrums where they sit.
So solving some of the problems of space.
Oh, okay. So SpaceX is obviously trying to get humans to Mars. They want to make humans a multiplanetary species. Whereas Blue Origin, Jeff Bezos' company, wants to have 1,000 people or 1 million people living and working in space. You know, both really crazy, noble visions, but ours is a lot more simple. We want anyone who could benefit from a satellite to be able to build and launch it. We don't necessarily need humans in space. So I'd say we're kind of on a completely different axis. Our vision is different, we're serving different customers, but if we have to go like one level deeper into the operations of the company, I would say that we're a little more like SpaceX. You know, we try to do things quickly. We're okay if our hardware breaks, whereas Blue Origin is, their company slogan is gradatum ferociter, which means slowly, step by step, ferociously. So they're moving at a slower pace than SpaceX. So we're definitely a little more like SpaceX, or at least try to be.
Yeah.
Thank you. So I'm Ashlyn Elkin, and I'm from UNH. And I had a question about confidence specifically. I know that you talked about, you know, when you were designing your space tug, you thought that you had done something wrong because it hadn't, you know, matched up with what everyone else was talking about. So I was more so wondering, how do you keep your confidence in not only yourself, but your ideas when working in industries that might not always support you?
Great question. Yeah, great question. So I think there's gaining confidence and then appearing confident. And I am very much a supporter of fake it until you make it. And so I'm going to answer this question in two parts. So part one, I have 3 responses. So how do you fake confidence? So 1, try to speak in absolutes. But if you're not quite sure about the answer, add a qualifier at the end. Don't use language like I think or I believe or maybe this could be true, which a lot of women obviously do add qualifiers. Don't do that. If you're unsure, at the end of a sentence, add based on the data I have available. So I don't think it's going to snow today based on the weather report I saw yesterday.
Gonna steal that.
The second thing that helps you appear confident is just to be concise. The third thing that I do is I always enumerate my responses where I can, even if I don't know what the third one's going to be. So 2 parts to this response, 3 different parts to the first part of that response. I make it up as I go, but it makes it seem like I have thought of an answer on the spot. The second part about building confidence is I have a personal mantra. So I have heroes who are women, and I always think like, pretend I'm Gwynne Shotwell. So she's the COO of SpaceX, for example. What would she do in this situation? And I play that role. Or if I'm being intimidated by a group of men, I'm like, oh, I try to think about what their weaknesses are. Like, you know, they've been in the industry for 40 years. They probably haven't written any Python code. I am probably way better at that than them. Like, there is an area where I'm a little more expert. So I try to like refresh myself on how I am expert in comparison to who I'm talking to. But I mean, ultimately, I think everyone has confidence issues, and if you don't, maybe you're suffering from Dunning-Kruger. Like, it's a good thing. It helps you receive feedback and grow as a person.
This reminds me of Jonathan's opening speech of remember who you are. And in those moments, you're reminding yourself who you are, which is very empowering. Thank you.
Thank you so much.
I think we have time for one more question. All right.
What is your biggest regret or mistake that you made in your career?
I'm sorry, could you repeat that?
What is your like biggest regret or like biggest mistake that you made in your career?
This is very specific to engineering. I wish I had built more hardware with my hands. In my free time, I was always reading books or working with computer code or studying, but I feel like I would have been a better engineer if I had just gone out and built things in my free time. And I think how this applies to everyone else is even if you don't have an internship or even if you don't have a job, like, do really powerful hobbies. Like, learning things through your hobbies can get you really far. And that's actually one thing that we look for when we're hiring people. But that's my regret.
I actually think we have one more, actually. Bonus question. Let's see.
Hi, my name is Aaron. I'm from Boston University. Would you be able to tell us where we can find more info about your space tug design and also maybe briefly describe what electric propulsion is?
All right, so to the first part of your question, come talk to me afterwards because our tech is ITAR controlled. So the second part of that question. So what makes our approach so optimal compared to others is really two things. First is our systems already reside in space, and they can be used for multiple missions, which frees up more mass and volume in a rocket for the payloads. So think about it, like there's a reason why you don't really have a direct flight from like New York to Singapore. Like it makes sense to stop and refuel on the way, and it's the same with rockets. Like it makes sense to break it into two stages from a physics and a logistics perspective. The second thing that makes our orbital transfer vehicles such a better solution is the propulsion technology. So in rocket physics, there are two metrics that we really talk about a lot. One is thrust, which is the horsepower, and the other one is specific impulse, which is the fuel efficiency. Now, because of chemistry and the way the world is, you can only get a certain fuel efficiency from chemical combustion. So rocket efficiencies top out at a metric that's around 450 seconds specific impulse. If you think about the best rocket engines ever designed by NASA on the space shuttle, like they're 450 seconds. You can't go above that. And in space, launching a rocket, the further you want to go, you need more propellant. And then you need more propellant to carry that propellant. So if you're fuel inefficient, the amount of propellant you have to carry compounds exponentially. The way to break this and go further and go faster is not to add more thrust, it is to have higher fuel efficiency or specific impulse. The way to do this isn't with chemical rocket engines, it's with electric propulsion. So our electric propulsion systems, we have a few different flavors, but basically, our first ones use a spark gap to create a plasma that we then accelerate with a magnetic field to very high speeds. The faster your exhaust is shooting out your rocket, the more efficient it is. And this is simply why we use an electric type propulsion system. Sorry for being long-winded.
Oh,
That was
no.
great. Thanks.
That was amazing. Well, Vanessa, your passion for what you're doing in your life right now is just contagious. And thank you so much for sharing it with us. And I know that there's so many golden nuggets that we're taking away and applying to our own lives. So thank you so, so much for being here today. And let's give another round of applause for Vanessa.